In mid-February 1943, at Sidi Bou Zid in Tunisia, the seized M4A1 Sherman tank came to a halt amid the desert sands, its U.S. star emblem faintly showing under the rushed overlay of a German cross. Members of Heavy Panzer Battalion 501 clustered around this trophy, sketchpads at the ready. This lone, intact and functional American tank, taken during the Sidi Bou Zid clash, would spark a wave of doubt among German designers that lingered across their armored vehicle projects until the war's end. The equations of tank combat stood on the brink of revision, not via greater armament or thicker plating, but via an aspect the Germans had overlooked: mechanical reliability that defied failure. The vehicle carried the inscription War Daddy 2 on its side. It bore serial number USA 30641, manufactured by Lima Locomotive Works and assigned to Company G, 1st Armored Regiment, 1st Armored Division. A German recon team piloted this Sherman over 350 kilometers of North African ground to the harbor at Sfax, enduring a trek lasting 4.5 days. Each mile exposed flaws in German views of U.S. manufacturing prowess. The motor stayed cool throughout. The gearbox held firm. The final drives delivered steady output. Crews from German units, used to constant breakdowns even on brief runs, observed with mounting concern as this foe's machine operated flawlessly across rough landscapes and harsh environments that would cripple their gear. Docked at Sfax, War Daddy 2 got loaded aboard a freighter headed for the Reich. The Wehrmacht Ordnance Bureau had mandated its delivery. Arrive at the Kummersdorf evaluation site fully operational and undamaged. Intelligence briefs had offered piecemeal insights into U.S. tank output. Yet, encountering the actual hardware transformed those figures into undeniable reality, far beyond mere documents. The Sherman embodied volume production on a level beyond German reach, crafted with engineering approaches the Germans hadn't perfected. As the vessel cut north through the Mediterranean, Wehrmacht technicians readied evaluation procedures to confront unpalatable facts about their constraints and Yankee strengths. By spring 1943, at the Kummersdorf test range near Brandenburg, Germany, War Daddy 2 descended from the rail transport labeled as Versuchskraftfahrzeug 239 with German plate WH 058941. Evaluators had already inscribed armor specs, thicknesses, and slopes onto every inch of its exterior, tagging spots for their thorough assessment regime. Situated 25 kilometers south of Berlin, the Wehrmacht's Kummersdorf facility handled rigorous trials for domestic and enemy gear alike. There, detail-oriented experts gauged, probed, and dissected elements like suspension tautness and drivetrain performance, compiling dense analytical dossiers. The Sherman faced the most exhaustive mechanical scrutiny German expertise could muster. Initial reviews involved squads of experts from diverse fields. They snapped images of each part from myriad viewpoints, gauged every gap using exact tools, and noted assembly methods that appeared deceptively simple next to German techniques. Driveline experts zeroed in on the gearbox right away. Unlike the straight-tooth setups in German tanks, which demanded tight fits and regular overhauls, the Sherman featured herringbone gears that spread loads over several contact points at once. This approach, routine in U.S. auto production since the 1930s, ensured remarkable longevity with relaxed machining needs. German specialists had dismissed herringbone designs as unfeasible for large-scale output, given their setup and skilled labor limits. Meanwhile, the Americans churned them out in vast numbers. Trials kicked off with standard mobility exercises to strain all systems in simulated combat scenarios. Operators maneuvered War Daddy 2 over custom barriers mimicking war zones, tracking fuel use, tracking motor heat, and logging gearbox responses amid diverse stresses and surfaces. Post-run, teams stripped down parts to scrutinize erosion, hunting evidence of strain, poor greasing, or inherent flaws. Findings upended core tenets of German armored strategy regarding compromises between capability and dependability. The Sherman met benchmarks across the board and surpassed them in the area where German vehicles faltered: uptime without servicing. The drivetrain review exposed philosophical divides in approach that the differences in American and German tank design philosophies were laid bare in several key ways. The Sherman's gearbox offered 5 speeds ahead and 1 in reverse, with synchromesh on the 2nd through 5th gears, which removed the necessity for double clutching in routine use. This turned the tank into something almost as straightforward to handle as a standard passenger car, demanding only basic skills from its operators. In comparison, crews on German vehicles invested hours mastering intricate double-clutch procedures and precise accelerator control to prevent harm to their drivetrains. The Sherman was built around the idea that regular troops with everyday car savvy could manage these beasts, whereas German engineering relied on elite, expertly prepared personnel. The specific Continental R975 radial power plant in this Sherman variant showed impressive adaptability to diverse environments. Designers observed that it delivered steady output over temperature extremes that would have overwhelmed or weakened German motors. Its cooling setup, basic yet robust, turned out to be exceptionally reliable. The intake filters coped with sandy conditions in arid zones without the constant blockages that tormented German armor during North African campaigns. Each component embodied a mindset favoring real-world reliability above abstract perfection. On June 6 and 7, 1943, at the Hillis-Lien Artillery Proving Ground, Reich Minister Albert Schaar stepped in to lead a crucial weapons summit, joined by top figures from the arms sector and high-ranking Wehrmacht commanders. The agenda featured slope-climbing tests pitting German models against seized Allied ones. War Daddy 2 was positioned next to cutting-edge German prototypes such as a brand-new Panther AUSF, D-Tank and a Ferdinand assault gun, showcasing the pinnacle of Germany's armored tech advancements. As the overseer of German weapons manufacturing and directly answerable to Hitler for outcomes, Schaar sought insights into U.S. industrial prowess and how his nation's vehicles stacked up against faux hardware. The trials revealed truths that neither Schaar nor the German developers cared to confront. The Sherman ascended the challenging gradient effortlessly. Its 5-speed manual shifter, synced from 2nd to 5th, engaged flawlessly without pauses. The motor sustained, even thrust all the way up. The operator guided the machine assuredly, highlighting the user-friendliness that defined Sherman's. The Panther came next, its potent 700-horsepower Maybach HL230 unit enabling it to keep pace with the Sherman, but just scarcely and with far greater effort. The Ferdinand, a colossal 65-ton behemoth with its intricate electrical drivetrain, ground to a halt midway. Schaar observed as tow teams labored to revive it, the humiliating breakdown unfolding in front of numerous top brass and factory executives. Decades on, in his recollections, Schaar reflected on the Sherman's strengths he'd witnessed during his October 1944 review of forces in Italy. He highlighted glowing feedback on its off-road prowess, with the tank scaling peaks that German specialists deemed impossible for such vehicles. He credited this to the Sherman's robust engine-to-weight ratio, which granted superior traversal over flat terrain compared to German counterparts. The 26th Panzer Division had explicitly flagged this edge. Such remarks from Germany's armaments chief resonated deeply in Wehrmacht debates. A published review surfaced in the Das Reich paper on June 27, 1943. It portrayed the Sherman as a standout achievement from North American workshops, deeming it a commendable output of U.S. heavy industry. The report spotlighted initial impressions of mass production and adherence to the bold standards of American automakers. It referenced the gyro-stabilized cannon as the pioneering effort of its type globally, recognizing Yankee ingenuity there. These carefully phrased announcements, tailored for morale-boosting spin without hinting at weakness, masked the growing unease rippling through German technical teams. U.S. tanks weren't merely sufficient, they were inherently superior for prolonged combat deployment. Returning to Kummersdorf, rigorous evaluations persisted from summer through fall 1943. Teams assessed the Sherman's endurance, running exhaustive runs that tested its boundaries. Records showed travel distances surpassing 2,000 kilometers with only routine upkeep, about quadruple the practical span of initial Panther variants under combat stresses. Evaluations of gearbox performance outstripped all. The German tank experienced far fewer power reductions in its drivetrain compared to similar setups in other German models. Experts reviewed its synchronized manual gearbox, which allowed effortless and straightforward shifts without needing double clutching or precise engine speed synchronization, as required by typical German transmissions. The final drive mechanisms offered yet another eye-opening insight that contradicted established German engineering principles. In Panther tanks, these systems drew from the Tiger's legacy, leading to breakdowns when subjected to heavy demands. They featured straight-cut gears within casings insufficient for the stresses of a 45-ton machine. Mechanics serving in North Africa and on the Eastern Front frequently noted final drive failures, resulting in Panthers being left behind after minimal travel, occasionally under 100 kilometers. Conversely, the Sherman's final drives, constructed with herringbone gears akin to those in its transmission, seldom malfunctioned, even during prolonged battlefield use that would ruin German equivalents. Much later, during restoration efforts, teams discovered Sherman final drives requiring no repairs after decades in storage, a clear sign of overbuilt tolerances that surpassed basic operational needs by wide margins. By the end of 1943, Kumdorf had gathered sufficient evidence to compile detailed reports distributed across Wehrmacht technical divisions. Aimed at high-ranking Wehrmacht leaders and armaments ministry personnel, these papers delivered a stark assessment of relative strengths. The Sherman highlighted the advanced state of American vehicle engineering, an area where Germany fell short despite its strong theoretical foundations and scientific prowess. Production methods enabled looser tolerances, dismissed as imprecise in German standards, but they yielded tougher vehicles better suited to real-world combat. The use of swappable components simplified on-site fixes using everyday tools and basic skills. In contrast, German machines demanded factory-grade accuracy and dedicated machinery for most overhauls, with the overall approach favoring sustained functionality over peak specs that dazzled on paper but proved fragile in action. German technical evaluations captured insights into U.S. industrial edges that extended past mere output volumes. American tank development stemmed from extensive civilian auto experience on a massive scale, something Germany had not matched. Prior to the war, cars were ubiquitous in the U.S., owned by everyday people from all walks of life. In Germany, personal vehicles were mostly elite luxuries for the affluent and regime insiders. The Volkswagen initiative, touted to laborers since 1934, had produced under 1,000 non-military cars by 1939. This gap in auto sector evolution directly shaped tank philosophies. U.S. designs enabled upkeep by technicians versed in civilian car work, drawing on familiar know-how. German ones necessitated advanced specialist instruction and ongoing oversight from experts with prolonged military tech backgrounds. As reports from the field piled up into late 1943 and early 1944, the reliability gap with German tanks grew undeniable. Panthers needed rigid usage limits to avoid breakdowns that immobilized them. Operators were cautioned against frequent gear changes as they wore out the transmission quickly. The third gear failed so routinely that manuals advised avoiding it unless essential. Backing up while turning was prohibited, lest it wreck the gearbox. Sharp pivots worked only on uniform terrain for both tracks, hampering maneuverability. Debris caught in the drivetrain could seize the sprocket, demanding lengthy fixes to resolve. Such issues persisted, even though Panthers came from specialized facilities, crafted by expert labor with top-tier resources at Germany's disposal. The Sherman, however, originated from auto specialists at General Motors, Ford, and Chrysler, who adapted long-honed mass production techniques from passenger cars. It integrated off-the-shelf auto parts where feasible, tapping into proven logistics and fabrication skills. Transmissions were sourced from various firms like Caterpillar Tractor, Buick, and Ford Motor Company, all adhering to uniform standards with parts that swapped seamlessly across units without tweaks. Such uniformity, commonplace in U.S. auto practices, was mostly aspirational in German manufacturing. In the realm of tank manufacturing, various producers incorporated minor differences that hindered full compatibility of components. More seized Sherman tanks continued to reach Kummersdorf during 1943 and 1944, encompassing vehicles captured from British forces in Italy as well as Soviet troops on the Eastern Front. Every such captured machine went through comparable evaluation procedures, which helped compile an extensive record of U.S. tank performance spanning multiple models and manufacturing phases. The British had upgraded certain Shermans by installing their 17-pounder anti-tank cannon, resulting in the Firefly version that remedied the tank's primary shortfall in offensive power. German technicians scrutinized these altered vehicles closely, observing how the Sherman's expansive turret ring allowed for the much bigger weapon with only slight adjustments. The Firefly highlighted untapped upgrade possibilities inherent in the base design, something German designers hadn't anticipated when outlining their own tanks. The Panther, hastily developed to challenge Soviet T-34s, offered no room for major weapon enhancements without a total overhaul of the turret and chassis. The Vehicle Assessment Initiative grew to encompass endurance tests tailored to mimic battlefield scenarios. Technicians piloted Shermans over vast distances off-road, logging all mechanical glitches, upkeep needs, and part breakdowns. They juxtaposed these findings against operational summaries from Panther and Tiger formations active on the Eastern and Italian theaters. The figures painted a clear picture of differing dependability. Throughout much of 1943, Panther availability hovered under 40%, with certain groups facing dire levels dipping to 20 to 25%. Some Panther battalions recorded stretches where barely 1 out of 5 vehicles could engage in fighting. In contrast, Sherman tanks sustained far superior operational rates in every campaign area. Detailed German frontline accounts laid bare the Panther's dependability woes. During Operation Citadel at Kursk in July 1943, Panthers managed just 16% readiness, as breakdowns sidelined more machines than hostile fire. By December 1943, that figure climbed to a mere 37%. Reports from February 1944 indicated 37% operational. April 1944 saw it hit 50%. In May 1944, it peaked at 78%. These percentages reflected the share of Panthers ready for action on a typical day, while the rest sat idle for spare parts or fixes. The trend indicated steady progress as initial defects were fixed, yet even peak Panther availability fell short of the Sherman standards right from the start of mass output. By December 1943, the evidence was irrefutable for anyone impartially reviewing the stats. The diesel-powered Sherman's engine endured over 3,000 km with routine care. The Panther's power plant, by contrast, struggled to surpass 1,000 km, despite fixes tackling the earliest severe issues. German assessments from March 1944 hailed enhanced Panther engines lasting 700 to 1,000 kilometers as a triumph. Yet this advance only aligned Panther engines with about one-third of the Sherman diesel's endurance. Sherman gearboxes needed little servicing between rebuilds, featuring meshed gears that reduced the risk of operator mistakes causing harm. Panther gearboxes, however, required ongoing monitoring and regular fixes, with third-gear breakdowns so prevalent that operators took to jumping from second straight to fourth to bypass the faulty setting. Sherman drive finals proved sturdy in situations that consistently wrecked Panther finals after just 100 to 200 kilometers. Accounts from German outfits deploying captured Shermans validated the Kummersdorf trials through practical deployment insights. As their native armored and infantry forces deteriorated, German motorized groups, starved for dependable rides, readily integrated any undamaged American tanks they seized. Unlike Soviet T-34s, which Germans overhauled heavily prior to deployment, Shermans joined German ranks unaltered. No tweaks proved necessary, as they functioned as intended without core defects demanding fixes. Crews from German tank units, scarred by repeated breakdowns in their domestic machines, marveled at the Sherman's steadfastness and often highlighted it in correspondence and debriefs. Dispatches from panzer regiments emphasized how Sherman handlers could concentrate on strategy and fighting prowess, whereas Panther and Tiger operators fretted endlessly over arriving at engagements uncrippled or finishing tasks before faults halted them. In January 1945, amid Operation Nordwind, the 10th SS Panzer Division seized 12 M4A3 Shermans near Hatton. These had come from the U.S. 43rd Tank Battalion and were taken whole when during the German offensive, the crews left those vehicles behind. These 12 Sherman tanks were integrated into the 13th Company of the 10th SS Panzer Regiment, participating in battles until the war's end. They functioned primarily as scout units and quick response reserves, demanding constant mobility without frequent repairs and dependable mechanical operation. German officers acknowledged the insights from earlier trials at Kummersdorf. U.S. tanks proved trustworthy when it mattered most. This reliability, rather than superior armament or defensive plating, ultimately shaped their battlefield effectiveness in the war's closing stages. A Sherman that reached the front lines with a working cannon held far greater worth than a Panther boasting better guns but stranded 20 kilometers back due to failure. In January 1944, testing initiatives broadened as Wehrmacht units pulled back on several fronts, bringing more seized gear to Kummersdorf. Technicians assessed the M4A1 equipped with the Continental R975 radial engine, recording its features and contrasting them against other models. They scrutinized the M4A2 powered by twin General Motors 6046 diesel units, highlighting its better fuel economy and unique handling traits. They also reviewed the M4A3 with the Ford GAA V8 gasoline motor, which U.S. operators regarded as the top Sherman engine option. Across all types, a core strength emerged: outstanding drivetrain dependability rooted in solid design fundamentals and high-caliber assembly methods. This uniformity across models struck German specialists who were used to wide discrepancies in quality from various firms building supposedly similar machines. The diesel-fueled M4A2 especially caught the eye of testers at Kummersdorf. Through Lend-Lease, Soviet troops obtained 40,002 of these vehicles, and many ended up captured by Germans amid Eastern Front withdrawals. Its dual GM 6046 diesels delivered capabilities on par with any Sherman while using far less fuel than gas-powered ones, a vital edge as German petroleum stocks ran low. Though German developers had toyed with diesel tank motors, they dropped the idea amid production hurdles and the intricacies of fuel injection tech. U.S. manufacturers churned out diesel Shermans parallel to their gas counterparts without halting assembly lines, showcasing production adaptability and advanced know-how that German facilities couldn't match under wartime pressures. By March 1944, updates from General Heinz Guderian, the Panzer Inspector General, appeared in formal dispatches stating that Panther upgrades had hit what he called tolerable levels by year's start. Engine durability extended to 700,000 kilometers, and final drive issues were mostly fixed via redesigns and better fabrication techniques. Presented in German Army reports as a major breakthrough, this progress merely elevated Panther performance to what Shermans had delivered right from their 1942 debut. The Wehrmacht hailed attaining benchmarks that American vehicles had surpassed from day one, underscoring the lag in German tank evolution. The gap widened further as production faced mounting shortages and intensified Allied airstrikes. Bomber offensives zeroed in on vital choke points in Panther and Tiger manufacturing with growing precision. On the evening of April 27 to 28, 1944, RAF Bomber Command hammered the Maybach engine works in Friedrichshafen with 322 planes, an assault labeled by Imperial War Museum records as the war's most crippling blow to German armor output. The strike leveled the nearby ZF transmission facility too. Engine and gearbox fabrication ceased entirely for 6 months. Upon restarting in November 1944, standards had slipped markedly. As conscription pulled German laborers into the forces, factories turned to forced workers, leading to intentional disruptions. Tobacco filters clogged lubrication channels, seals were fitted wrong, parts went together without adequate tolerances. Such defects never plagued Sherman lines, secured in distant U.S. plants away from fighting, run by dedicated staff paid well in fair settings. The core disparity in American versus German tank making wasn't about technical expertise, but industrial capacity and core design approach. German experts grasped vehicle mechanics just as thoroughly as Americans, with deep theoretical insight and research prowess. They merely failed to implement those concepts reliably in tanks, opting instead to prioritize other elements played a role as well. German armored vehicles prioritized performance metrics that yielded striking technical specs, yet they suffered from subpar dependability in real-world operations. The Panther boasted a potent 75mm K2 cannon and robust front plating, but these came with a strained drivetrain unable to consistently handle the machine's 45-ton mass. The Tiger's impressive strengths necessitated intricate upkeep routines and regular fixes from skilled experts. Such compromises might have worked if German manufacturing could churn out sufficient numbers of tanks, along with ample replacement parts to keep them operational. That proved impossible, especially as Allied air raids escalated and supplies of essential resources dwindled. U.S. designers, schooled in high-volume assembly from years in the consumer vehicle sector, crafted tanks suitable for production in the tens of thousands, serviced by technicians with everyday skills from non-military jobs. The Sherman's drivetrain incorporated parts validated in everyday commercial use, drawing straight from car and truck production methods. Its electrical setup featured a secondary generator capable of driving the turret rotation even if the primary motor quit, an extravagance German engineers dismissed as superfluous, though it saved lives in battle. Crews in German tanks could only envy such perks, especially after dealing with turret jams when motors died on inclines. These innovations never made it into German design docs, as their creators focused more on plating depth and firepower than on such details. Come spring 1944, Wehrmacht formations across every sector logged rising technical glitches amid falling build standards and vanishing spares. Panthers needed rail haul for any trip over 100 kilometers, since their end drives buckled under prolonged highway travel. Frontline directives banned unnecessary Panther travel to save them for fights, not fritter them away on transit breakdowns. Even the Berge Panther, a rescuer variant on a Panther frame meant to tow out broken ones, inherited the identical frailty issues. German leaders confronted a harsh truth. More vehicles fell to mechanical woes than to foes, with certain outfits citing 70% of losses from failures over battle hits. At the same time, Sherman output surged to levels German factories couldn't rival. U.S. plants built 49,324 Shermans over the conflict, outstripping the total of every German tank variant put together. Commonwealth allies got thousands via Lend-Lease aid. The Soviets took delivery of more than 4,000 diesel models. In Burma, Chinese troops wielded Shermans to crush Japanese armor, which lagged behind both U.S. and German tech. In every campaign where Shermans fought, they validated the insights from Kummersdorf trials. Well-kept Shermans stayed mobile in scenarios that wrecked or immobilized German heavies. German operators who seized and operated Shermans consistently lauded their mechanical prowess in wartime dispatches, accounts, and later recollections. Dispatches from the East highlighted how Wehrmacht repairmen deemed the intricate Chrysler A57 multibank, its 5 distinct engine units, simpler to diagnose than the specialized German power plants needing expert tools and know-how. Allied tankers hailed the Ford GAA V8 for its outstanding durability and thrust, which struck German fixers as extraordinarily solid next to Maybach units demanding endless tweaks to valves, sparks, and fuel mixers. The General Motors twin diesel, which the U.S. military had sidelined as inferior to gas motors and shifted to Lend-Lease runs, outperformed and outlasted every diesel power unit Germany had fielded for tanks. The Sherman's ample engineering buffers offered yet another edge that German developers eventually recognized. Core gearbox and end drive pieces, first rated for the 30-ton M4 with 400 horsepower, needed few alterations to manage the 42-ton M4A3E2 Jumbo's beefed-up shielding. Those identical parts that drove the regular Sherman flawlessly channeled 650 horsepower from testbed motors with no breakdowns or bolstering required. German designers often viewed this kind of over-engineering as squandered effort, surplus heft that hiked costs and gobbled rare resources for no quick payoff. Their American counterparts grasped that these buffers enabled future enhancements and on-field toughness, justifying the added expense across the tank's full career. By summer 1944, Germa tank commanders on the German side during the Allied landings in Normandy were well aware that their mechanical shortcomings went well beyond the performance of single vehicles. The U.S. dominance in artillery, effective airstrikes in close proximity, and superior supply chains worked together to overpower the Wehrmacht, no matter how advanced the tank models or clever the battlefield tactics. Yet the Sherman's dependability allowed U.S. armored formations to keep up relentless engagements that panzer units could never sustain. American tank groups were able to initiate assaults, hold fights going, chase retreating foes, and swiftly gear up for follow-on actions without major downtime for repairs. By contrast, German panzer outfits had to meticulously manage their scarce working machines, figuring that each maneuver shortened the lifespan of vital parts and edged them nearer to breakdowns. This gap in readiness for action decided which side could keep up the push and which needed to conserve its scarce fighting strength. The Wehrmacht's deployment of seized Shermans in battles offered the ultimate evidence, from a German viewpoint, of U.S. engineering excellence. The 150th Panzer Brigade, put together especially for stealth missions in the Ardennes offensive of December 1944, sought out captured U.S. armor to mask their movements. Planners in Berlin chose Shermans precisely for their famed durability. Still, the unit got just 2 of them, with only one fitting enough for use. That working Sherman ended up unused in actual fighting, because severe congestion blocked the infiltration plan from succeeding. For a mission demanding machines that ran smoothly without hitches deep in hostile territory, cut off from help, just American gear gave a solid shot at pulling it off. Even top-conditioned German tanks couldn't promise the non-stop reliability those tasks demanded. On January 23, 1945, came the last formal acknowledgement of the Reich's vehicle woes. A session of the Panzer Commission yielded a report outlining disastrous breakdowns in final drives for every German tank class. Its conclusions hit hard. Before the 1945 push on the Eastern Front, defects numbered 500 in the Panzer IV, 370 in the Panther, and about 100 in the Tiger. On top of that, around 200 issues cropped up in the Hetzer tank destroyer, built on the Czech 38 Etoile frame. General Wolfgang Thoma, Lieutenant General and top aide to the Inspector General of Panzer Forces under Guderian, laid out the effects bluntly. Under those conditions, proper deployment of armor became out of the question. Soldiers lost faith in their rides and, in certain cases, ditched entire machines over final drive troubles, worried they'd get stuck and taken prisoner. German designs, meant to awe with cutting-edge specs, fell short on the basics every armored vehicle needs: toughness to get to the fight and finish the job. The Kummersdorf Proving Ground readied for pullout in early 1945 as Red Army troops surged toward the capital. Staff rushed to crate up test results and send records to safer spots in the West, aiming to safeguard know-how for after the war. Among the grabbed vehicles, including at least 2 Shermans, some got thrown into hasty frontline duty with outfits holding back the tide into Berlin. These machines battled next to homegrown German ones in the last frantic clashes, yielding one more real-world matchup. The Shermans kept running until blasted apart or ditched from lack of gas. German models, from Panthers to the handful of Tigers left, quit due to mechanical glitches at levels that stunned veteran operators used to shoddy build quality. The tale of War Daddy II and the many other Shermans evaluated at Kummersdorf highlights one of the biggest production gaps of the Second World War. Engineers in the Third Reich, trapped in a setup that favored abstract ideals over real-world use, built tanks that shone in blueprints but crumbled in prolonged combat. U.S. designers, drawing on years of car-making savvy for war needs, made tanks short on fancy tech in spots, but steady in scenarios that wrecked German hardware. In tank battles, like so much of warfare, the tool that performs on cue trumps one that's perhaps better in theory but can't make it to the field or get the task done. After the war, reviews by U.S. and U.K. spy agencies backed up what Kummersdorf trials had shown. In-depth looks at wrecked German tanks uncovered mechanical breakdowns, proved just as frequent as battlefield wounds when it came to disabling vehicles. Final drives shattered under excessive strain, transmissions locked up due to poor lubrication or driver mistakes, and engines gave out from excessive heat or lack of oil. The Germans' fixation on crafting singularly superior machines with dazzling specs had obscured the vital need for dependability and ease of upkeep. They engineered tanks that no ordinary draftee could service without in-depth expert training, fueled by motors requiring ongoing oversight from proficient specialists, and backed by a supply chain that buckled beneath the weight of delivering myriad bespoke components to dispersed formations. Insights gained from trials at Kummersdorf profoundly shaped post-war tank development in West Germany's Bundeswehr. As the Federal Republic embarked on the Leopard 1 main battle tank project during the 1950s, engineers intentionally prioritized durability and serviceability ahead of sheer performance metrics. They drew from U.S. automotive design methods and intentionally integrated them into armored vehicle creation. The Leopard 1 thus adopted numerous concepts that had propelled the Sherman to prominence. A sturdy drivetrain with generous safety buffers, straightforward servicing that needed few specialized implements, interchangeable parts for quick frontline fixes, and adaptability for later enhancements without full overhauls. The Leopard 1 emerged as one of the Cold War's standout tank platforms, adopted by many forces and manufactured for years on end. The seized Shermans at Kummersdorf, such as the one dubbed War Daddy II with its bold hull inscription intact, stood for much more than mere faux hardware hauled back for dissection. They embodied concrete evidence that mature industry and pragmatic engineering rooted in real-world trials outweighed abstract tech breakthroughs chased in isolation from production constraints. German armor experts chased cutting-edge features in the conviction that advanced engineering could surmount shortages in resources and manpower. They erred. U.S. tank builders crafted dependable machines informed by tough lessons, recognizing that supply lines, repair proficiency, and ongoing combat readiness clinched triumphs in contemporary mechanized battles. They succeeded, and their strategy emerged as pivotal. The chasm in dependability between Sherman's and German designs didn't merely affect frontline tank clashes, it redefined wider views on military-industrial prowess and its pivotal function in contemporary strife. Germany launched into World War II holding edges in various armaments, boasting scientific acumen and technical mastery, surpassing many rivals. Yet Germany fell short on the manufacturing breadth and production finesse needed to sustain those leads amid high-volume output while battling foes across several theaters. The United States joined the conflict with gear that lagged in technical refinement in several areas, but wielded the factory might to churn them out in vast numbers, all while refining quality, sturdiness, and capability via battlefield input. This manufacturing mindset, vividly illustrated in the Sherman tank's conception and assembly, outshone Germany's high-tech finesse confined to limited runs. The U.S. churned out almost as many Shermans alone as Germany managed across every tank variety total, while also mass-producing all manner of other arms, aiding partners via Lend-Lease and upholding the loftiest quality of life among warring powers. Such fiscal achievement, beyond Germany's reach even prior to escalated aerial assaults, sealed the conflict's result as surely as any clash. The equation boiled down to stark, unforgiving arithmetic under scrutiny. A Sherman armed with a 75mm cannon that arrived intact at the front and performed solidly held boundless worth over a Panther, boasting a better weapon that stalled short of contact or demanded 3 days' work for each day in action. An armored unit where 80% of machines stayed battle-ready could carry out tasks impossible for one operating at 40% strength. Dependability transcended mere practicality or afterthought. It formed the bedrock of combat utility, dictating if tank groups could fulfill their directives. German tanks routinely flunked this core benchmark across the war. American tanks routinely aced it. Kummersdorf evaluations had established this irrefutably by mid-1943, even while German leaders persisted in fielding Panthers and Tigers that appeared intimidating and featured striking stats. But Co-1 couldn't count on German tanks to operate reliably during critical moments. The Sherman didn't secure victory in World War II via advanced armaments or superior defensive plating. Instead, it triumphed thanks to manufacturing dominance shown in its dependable mechanics, steady supply, and straightforward upkeep. By the middle of 1943, specialists at Kummersdorf had grasped this truth after thorough evaluations. They produced comprehensive documents outlining their observations. They validated the data multiple times using precise methodologies. They arrived at accurate insights regarding U.S. strengths. Yet, recognizing an issue and addressing it present entirely distinct obstacles. German manufacturing couldn't pivot toward dependability-focused assembly lines amid a doomed conflict across various theaters against foes boasting greater assets. U.S. factories had embedded durability into their non-military vehicle industry through years of market rivalry and effortlessly adapted those refined approaches to wartime output with impressive results. War Daddy 2, that lone Sherman seized in Tunisia and scrutinized intensely at Kummersdorf over several months, revealed the full narrative via its steadfast engineering and uniform operation. Each mile it traveled faultlessly highlighted how German armored vehicle development had veered disastrously off course, favoring specs at the expense of dependability. Each evaluation, showcasing U.S. vehicle prowess, confirmed that established production expertise and hands-on fabrication know-how outweighed abstract efficiency metrics. Each side-by-side assessment of Sherman versus German tank sturdiness demonstrated that Americans had tackled issues German experts hadn't even acknowledged as problems. The vehicle was ordinary in numerous respects, merely one among 49,000 built, but its implications shattered German morale, serving as irrefutable evidence that the Reich had forfeited the production battle long before combat ended, and that no amount of Teutonic engineering prowess or battlefield acumen could rival American output might.